All right, guys, what we're doing, our next chapter and our last chapter is chapter 5, rational expressions and chapter 5, rational expressions and rational exponents. So rational, we're talking about, especially here, fractional exponents or radicals. This is our chapter over radicals, our square roots, cube roots, fourth roots, any of these here. Now the first question that we're going to look at is this here. Which is greater, square root of 64 or the cubed root of 64? Now we talk about the square root of 64. We normally write it like this here. We don't write the index. The number inside that little v is the index. It's telling us how many times the number is being multiplied by itself. So the square root of 64 would be 8, because 8 times 8 is indeed 64. Now the cubed root of 64, we're looking for a number times itself 3 times. And well, the cubed root of 64 would be 4, because 4 times 4 is 16. And if we do 16 times 4, 4 times 6 is 4, 24, 4 carry the 2. 4 times 1 is 4 plus 2 is indeed 64. So the square root of 64 is going to be bigger or greater than the cubed root because we're multiplying a number by itself more times, which means a smaller number. Because if we looked at, say, the 6th root of 64, well, what times itself 6 times is 64 would be 2. Because the more times we multiply a number by itself, the bigger the number gets. When we look for a bigger root, the smaller the number gets. It's being multiplied by itself more times. Now, previously, you learned that the nth root can be represented as a rational exponent. The nth root of a is equal to a to the 1 over n, a fractional exponent. Or we could say that also the nth root of a to the x is equal to a. So again, it's going to go to a fraction. Our index of this radical is going to go on bottom, and the power is going to go on top. So the nth root of a to the x is the same as a to the x over n. So this helps us, or is nice in some ways, is we can rewrite a radical as a fractional exponent. And incidentally, we can rewrite a fractional exponent back as a radical. We can switch from one to the other back and forth. Nth roots, real nth roots. The main thing we'll focus a lot of this chapter on is the real roots of a solution, or the real values. We're not going to focus so much on our imaginary or complex. We're mainly focused on the real ones. Now, if the root we're taking is an even integer, so we're taking the square root, the 4th root, the 6th root, the 8th root, the 10th root. If we're taking the even root of a number, we have 3 choices, or 3 possible outcomes. So we're taking an even root. So number inside here is even. Now our a value, if a is less than 0, it means the value of a is negative. So it'd be, say, taking the square root of -4, or the cubed root of -8, or the square root of -8. There is a root. We can take it, but it is not a real number, because the square root of -4 is 2i, plus or minus 2i. It is not a real number. There is a root, it's just not real. And here, again, we're wanting to find the real nth roots of a. So when we're taking an even root, and a is less than 0, a is negative, there are no real roots. If we take an even root of a negative number, there are no real roots. There are imaginary roots, but there's no real roots. Second case is that a is equal to 0. Well, doesn't matter how many roots, we take the square root, cubed root, doesn't matter what root we take of 0. Because again, when we take a square root, any of these roots, we're saying what times itself, what number times itself, this many times gets us the number inside. Well, if the number inside 0, what number times itself, say 4 times, gives us 0? Well, that would be what? 0, because no matter how many times I multiply 0 by itself, it is still 0. So the fourth root of 0 is still 0. We will have one real root. It's 0, but we have one real root. And the last case is if a is greater than 0. A is any positive number. If a is greater than 0, we have 2 real roots. And we've gone over this before because the square root of 4 is 2. So if I said a number times itself 4 times, well, it could be the positive number or it could be the negative, because when we multiply a number by itself an even number of times, it's going to become positive. So we have a positive negative case. Okay? Questions on this so far? So we're taking an even root, or applying an even radical root to a number. We could have one of 3 options: either no real roots, one real root when it's 0, or 2 real roots, positive, negative. We have the plus or minus. So we got that one down. All right. Now, if n is odd, if n is an odd root, we're taking the odd root, so the cubed root, 5th root, 7th root. The number in that index is an odd number. The first case we have is when a is less than 0. The number inside it is less than 0. It's negative. And if it is negative, we have, well, one real root. I can take the cubed root of -8 and get a number. We can take the cubed root or 5th root or any odd root of a negative number. It works just fine. Because if you multiply a negative by itself, say 3 times, negative times a negative is a positive, times a negative one more time is a negative. We can take the odd root of a negative number, and we get one real root. Well, if a is equal to 0, again, just like when the root was even, we do get one real root. It's 0, but we do have one real root. And if a, the last case, a is greater than 0, a is a positive number. Incidentally, we get one real root. And it's whatever that number is. Doesn't matter if it's positive, negative, or 0 with odd integers. We get either one real root, or one real root. So really this here, the one that actually has more than one situation or one possibility is when the root is even. So let's see how this works. Find the indicated real roots, nth roots of a. So we have our radical. Now with a, it says that n is 3. And again, we're working with the nth root of a. So it's saying our index for this first one here is 3. The number inside is 216. So we don't have an x, we don't have a power with it, so that kind of makes it a little bit nicer. Yes. Now, for this here, we have an odd root of a negative number. And according to what we just said, if it's an odd root of a negative number, we have one real root. So we have one number that works. So we're trying to figure out what times itself 3 times is negative 216. Now, luckily for us, if we want to, we can grab either calculator and say 3 second root. With the 30xs, it's this x root. The graphing calculator, we have to go math and down to it to find it. And we can type in negative 216, which tells us it is -6. And our one real root for this here is -6. That's it. Yeah. I mean, we can do this by hand and we can figure this out. So if we look at, say, b, the fourth root of 81. So we'd set up our radical. N would be 4, and our a value would be 81. Now we need to see what number times itself. 4 times is 81. So let's factor tree. So 9 times 9. 3, or 9 would be, well, 3 and 3, 9 is. So our factor treed version is telling us that 81 is indeed 3 to the 4th. So what number times itself 4 times is 81? 3. So the fourth root of 81 is 3. Now before we say this is done, let's look, this is what we were saying a minute ago. We are taking an even root, yes? A is greater than 0. A is positive, yes? So how many real roots do we have? 2. Because it is positive, or 3, but it's also -3. It is +3 and -3, because we're applying this root to it. That's the main difference when we need to look at this. Because if I just asked you to simplify the fourth root of 81, it would be 3. But we're applying that root to it. We're saying what times itself 4 times is 81. We have positive -3. Because -3 to the 4th power is indeed 81. 3 to the 4th power is indeed 81. There is a very slight difference between those two statements, because if I just told you to simplify, I just gave you the fourth root of 81. Simplify it. It's 3. Here we're applying that root to it. We're solving for that x. What times itself 4 times is 81. That's where we get that plus or minus. It's a very small difference, but that's the difference. Okay? All right. Let's look at number 1. 4 is our index. The number inside is 16. The fourth root of 16. So we're looking for a number times itself 4 times. That gives us 16. It's 2. We can do it in the calculator. Does give us 2. Now because it is an even root, we're applying an even root to it. It's an even root and positive. We have to put the plus or minus because there's 2 possible cases for this here. Now it will come a time, I mean, there are some cases where they will ask you, I don't know as much here, we'll see, but especially in college algebra, to simplify the radicals with these higher powers, you're going to have to type some of them out because the calculator won't take, say, the fourth root of 32. 32 is 16 times 2, so the 16 part of it would come out as 2, but we would be left with the fourth root of 2 if it doesn't simplify nicely. Square roots, fine, and the 30xs. Anything above a cubed root, we'll have to do by hand. Number 2. Well, so we have an even root, yes? And the a value is what? -49. It is a negative. It's less than 0, yes? Now there are roots, but are they real? No, it would be plus or minus 7i. But what is the problem asking for? To find what? Real roots. So there are no real roots. It's not that there are no roots, but there are no real roots for this here. We say no. No. So what is our index? What is the number we're taking this of? 3. So the index is odd. We're taking an odd root. Well, if the number inside odd root of a negative number, we should get what? 1 real root. So the third root of negative 125 is actually negative 5. Now, we can see that here. Because what we're saying is we're multiplying negative 5 by itself 3 times to get negative 125. Now, negative 5 times negative 5. Let's look at just the first two. The negative times the negative would give us a positive. 5 times 5 is 25. But then we have to multiply that 25 by negative 5 one more time. Well, 5 times 25 is 125. But our positive times a negative makes it back negative. Does that make sense? So it is a real root. It works because we multiplied by a negative once, twice, 3. 2 makes it positive. The third makes it back negative. Does that make sense? Huh? Because because here, that negative, there's no way to multiply two numbers by themselves. Number by itself and get a negative. Because anytime we multiply a negative by a negative, we get a positive where the positive is still a positive. There are roots. It's 7i. I is not real. In this whole section, this part of the section, we're looking for real roots. So we can't take an even root of a negative. It just doesn't work. Go through 243. 3. Yep. 3 to the 5th. 243. Because if the index, the root we're taking, is an odd number, there's one of 3 solutions or types of solutions we can get. It's either going to be 1 real root, or 1 real root. We will get 1 real root no matter what the index, if it's an odd index. There are other solutions to it. There are, especially for the last one, the 5th root of 243. If we wanted to find all the values, there are 4 more, but all of them are not real roots. For odd roots, so the 5th, what times itself 5 times is 243. The 1 real root is 3. The other 4 are complex roots. We have I, we don't have real roots. But here, we're only looking for the real root. Okay. Most of these here, there's a good number we can just use the calculator for, because not everything is going to come out as a nice root. So the square root of 5 cubed, well, the square root and the cube won't cancel. And then we can do square root of 5 cubed is going to be 11.18. We can do some of these in the calculator. B would indeed be 1. Yeah. Because the 4th root of 4 squared. Now, what? Yes. I don't know where I got 5. Probably from the 5. 1/8. Yep. No, that's right. So with B, we can type it in the 4th root of 4 squared. And I believe the calculator gives us 1, yes? 2. Thank you. 2. Now, let's look at this here also. I'm going to, according to what we've said already, the nth root of a is a to the 1 over n. So for this here, the 4th root of 4 is the same as 4 to the 1/4. Powers of powers multiply. So our 1/4 times 2 is 2/4. 2/4 is the same as 1/2. So we're looking also at 4 to the 1/2. We can simplify those radical sum. Now, going back, because again, the nth root of a to the a is the same as a to the 1 over n. Well, it's also the same as saying the square root of 4. What is the square root of 4? So sometimes it's nice to have them in fractional form. Sometimes it's nice to have them in radical form. Yes. Brad. Yep. Cube root of 9 squared. Root of 9. 4.326 or 4.33. It just depends on the instructions. If it says second decimal place 2, if you're not sure, give me more. I don't mind having. I'd put 3.3 if you round to 2 places. Because it's all dependent on that third spot. If the third spot's 5 or greater, we round up. If it's less than 5, we round down. And what'd y'all get for the last one here? Yep. Questions on these here? We good with these here? All right. Yes, because fractional exponents and these here both work the same. Now, I will show you with this first one here, 8 to the 2/3, it's actually possible to do these without a calculator. Because if we think of 8, if we did the factor tree, well, that's 8 is the same as 2 times 4. 4 is 2 times 2. So we can say 8 is the same as 2 to the 3rd power. So I'm going to replace 8 with its prime factorization. So 8 to the 2/3 is the same as 2 to the 3rd to the 2/3. Powers of powers do what? Multiply, yes? So 3 times 2/3, well, we could say that is 6/3, or well, 6/3 is just what? 2, yes? 2 squared is? And I believe the calculator also told you that 8 to the 2/3 is 4. Because 6 to the 5/2. The 2 on bottom, again, it's telling us what root we're taking. Because if the 2 is on bottom, we're talking about a square root. Times itself twice. Well, is there a number that multiplied by itself twice that is 6? No. So most likely, this is going to give us a decimal answer. 6 to the 5/2 is 88.18. For the most part, yes. Now, what's interesting is if you notice 2/3, 5/2. 2/3, is that power bigger than 1 or less than 1? It's less than 1, yes? If I put a number, so we'll say 8, to the first power is what? 8, because 8 times itself 1 times would give us 8, yes? 2/3, less than 1, so it's less than 1, so it has to be smaller than 8, yes? Cubed root squared, yes. The next one, 6 to the 5/2, that is bigger than 1, so it's going to get bigger, because 5/2 is the same as 2.5. What's the square root of this number? Take that and square it. Essentially, not really, but yeah. So 12 to the 3/4, do we think we should get a number bigger than 12 or less than 12? Yes, and it is. Yep. 10 to the 3/2. That's it. Thank you.